Now the next redistribution we will see in this video is redistribution of from RIP to OSPF. So here also I'm going to take the same 3 router scenario where I got this router part. This part is running RIP and this part is running OSPF. And by default, the routes which are advertised by RIP, OSPF cannot listen to those routes, or it will not able to see those routes. Same thing happens opposite side as well. Now finally, I want to ensure that router 1 should be able to see router 3 network, 30 network, and router 30 network should be seen on 1 and 10 network should be seen on router 3. End-to-end communication, even though they are running different protocols. So we do distribution of RIP into OSPF. We have to do mutual redistribution, where we have to redistribute the routes into RIP as well as from RIP into OSPF, both the sides, and the router must be running both the protocols on at least one interface. And also we need to manually change the metric. That is something we need to do. So let's go ahead and verify what is the first redistribution we'll see. We'll see distribution of OSPF into RIP first, because we already seen how to redistribute into RIP. So we'll see this first one. So the first thing, it's a destination protocol is RIP. So we need to go to router RIP and then we need to say redistribute OSPF, and we are using process ID of 1, and then we need to define the metric in terms of hop counts, because we are redistributing into RIP. So whatever the protocol, irrespective of what protocol you're using as the source, okay, we need to ensure that we must define the metric in terms of hop counts. Okay, so similar way, once you do this, you should be able to see the 30 network will be coming on the router 1, but this 10 network will not be seen on the router 3, because we need to do other way redistribution, that is from RIP to OSPF. So again, if you want to do RIP to OSPF, we need to get into the OSPF protocol mode, router OSPF 1, and then we need to say redistribute RIP. This is my source protocol, and there is something called subnets we need to define, mandatory. So if I don't give subnets, what happens is, by default in OSPF, the default behavior is it will only redistribute classful networks. By default, OSPF will only redistribute the classful networks, which means the default networks like /8 A class, /16 B class, /24 C class, something like that. So if you want to redistribute classless networks also, then we need to manually define saying the keyword called subnets. So when I say subnets, it means that we are going to use the subnetworks as well. So let's go and verify practically here. The first thing, what I'll do is, I'll come to the remaining options as well. Let me just finish off with the basic configuration. The first step, I'm going to configure the basic advertisements as per my diagram. So on the router 1, I'm going to configure router RIP version 2 network, 10 network in the LAN and 1 network in the WAN. Note of summary. Okay, similar way on the router 3, I'm going to run OSPF. I removed all my previous routing configurations, so it's like a blank routing configurations. So router OSPF 1 network, 30 network in the LAN with a wildcard mask of /8 and then area 0, and then advertising the WAN interface as well. But the router 2 is running both the protocols. So as per my diagram, router RIP version 2, the 1 network and 20 network are running RIP. So I'm going to say 1 network and 20 network are running RIP, and the other interface, that is my 2 network, is running OSPF. So I'm going to say 2 network, and then I'm say 0.255.255.255 area 0. Now once I finish this, the router 2 and 3 should form the neighborship. And on the router 2, if I use show IP route, I should be able to see the route coming from RIP. Here you can see the route coming from RIP, that is from router 1, and I should be able to see the route from router 3, that is 30 network, as OSPF routes. So I'm able to see this 30 network as OSPF and this route coming as RIP, but on the router 1 I cannot see 30, and on the router 3 I cannot see 10. And the reason is simple, they are running different routing protocols. Now I want to ensure that they should exchange the routes. So what I'm doing is, I'm going to do redistribution of OSPF into RIP. So into RIP, OSPF redistributing into RIP. So I'm going to do this one into RIP, this commands. So let's configure these commands on the router 2. So I'm going to say router RIP, and I'll say redistribute. What's the source protocol? OSPF 1. And any protocol, anything you redistribute into RIP, we need to define the metric in terms of hop counts. So let's say I'm using 5 hop counts as per my diagram here. So once we do redistribution, now router 1 should be able to see the 30 network as a RIP route. If you give show IP route RIP, now I can see 20 network as well as 30 network, and I can see 30 network is coming as with a metric of 5 because we defined the metric of 5 hop counts for all the routes which are learned or redistributed into RIP from OSPF. But again, on the router 3, I cannot see the routes. If I give show IP route on the router 3, I cannot see the routes because we need to configure the other way redistribution from RIP into OSPF. So let's go to router 2 again. This is my router 2. So I'll go to router 2 and I'll say router OSPF 1 redistribute. The source protocol is RIP, and I'm just going to press enter. Whenever you press enter, it says a warning message saying that only classful networks will get redistributed. So if you don't want, if you want to include the subnetworks as well, we just need to use a keyword called subnets. You can see there's a keyword called subnets. Consider the subnets also at the time of redistribution. So most of the time we use subnets because in the production networks you will definitely find subnets. So probably it's a best practice. You just need to keep in mind whenever you do redistribution anything into OSPF, we need to use a keyword called subnets so that I can include all the subnetworks. But now there are 2 other options which we can configure, but these 2 options are I can say optional. Now optional means why it is optional? That's the first question. Metric, as I said, metric is mandatory, we need to define, but in case of OSPF, defining the metric is optional because for all the external routes redistributed into OSPF, it's going to take the default metric of 20, the cost of 20, that is the default cost it is going to take. You want to check? Let's go to router 1 and check, not router 1, I should see on the router 3, I should see show IP route OSPF. Now the first thing, you will see the routes as either OE1, you will see different kinds of routes. You will see O routes, nothing but the routes coming from the same area. We can say OIA routes. This is something what you have seen in the basic OSPF concepts, routes coming from a different area. And also you will see either OE1 or OE2. Now OE1, OE2 are actually, these are considered as external routes, the routes which are redistributed into OSPF, and we have metric type 1, metric type 2. So probably this is something I'll get into more in detail as I go. Probably let me just give you some idea on OE1 and OE2. So the default one is OE2. As of now I'm not defining anything because the default metric, let me just check the metric here. You can see the default metric is going to take 20 and the default metric type is E2. So which means even though if you don't define these values, default it will take 20, and if you don't define this value, default it is going to take a metric type of E2. Okay, so metric type I'll be discussing more in detail. Let me just finish off with this one. Okay, so what if I want to use a metric other than 20? No problem, you can define with a metric command. So let's go ahead and make some changes. I'll say redistribute subnets, but this time I'm going to say the metric of 100 instead of 20. So let's go and check on the router 3. So if I give show IP route OSPF, you can see here. Okay, now here you can see the options here. When I used a default metric of 20, it has taken a default metric of 20, but I used an option with a metric 100, so it changes the metric to 100. So if you don't want to use the default metric, we can still define the manual metric with any number, any cost value, whatever you want, but it's optional. But there is one more thing, one more option. We have something called metric type. Let me explain you what is this metric type in EHRP. Now in OSPF. In OSPF, we got 2 kind of external routes. We have something called external type 1 and external type 2 routes, and the default external type is E2. Now the difference between these two is, let's take an example. I got some set of routers here and I'm doing some redistribution of routes here, and these are the routes learning from RIP, or it can be EHRP, it can be any other protocol. And this entire red routers, you can see this is my OSPF. Let's assume that the cost from router 1 to router 2 is 10, and here it is 20, here it is 10, and maybe here is 40, and then 20 here. Assume that is the link cost between each and every router. And now what I'm doing is I'm getting into this router, and then I'm going to give a command called redistribution. I'll say redistribute. Inside the OSPF mode, we'll say router OSPF 1, and then I'm going to say redistribute RIP routes, and then subnets keyword, and then I'm going to define the metric of 100, let's say, and then I'm not giving anything. If I don't give anything, default it is going to take a metric type of E2. So now in case of E2, the behavior is different, and when you compare with E1, so which means I'm redistributing these routes with a metric of 100. So the metric will be 100 on this router. If you check here, it will be 100 on this router. If you check, it will be 100 on this router as well. If you check any router inside the OSPF, the metric remains the same. So in metric type E2 is not going to add the individual cost, or it's not going to use the individual cost whatever you have here. So it's going to use the same metric whatever you define at the time of redistribution. The same metric is used everywhere. But when you come to E1, the metric type E1, which is something we prefer to use, at the time of redistribution it is 100, but once it reaches this router it becomes 120, and once it reaches here it becomes 160, once it reaches here it becomes 170, and here it will become 190, and it will become 200 here. Now if you see the metric type E1, at the time of redistribution we are giving as 100, but it is going to see the cost. It's going to add this cost plus 20, it becomes 120. It's going to add the cost here 40, it becomes 160, 170, and so on. So the major difference between these two metric types is E1 will add the individual cost along the path, but whereas E2 will not add the individual cost, and it's going to be the same cost. Even though if you cross any number of routers, the entire OSPF domain will have the same cost whatever the size of the network you have. So this is one of the major difference between these two, and practically most of the time we prefer to use metric type E1, which is something more recommended, because we really don't want to have the same cost even though it crosses 100 of routers. So it's always recommended to change the metric type to E1, but default it will be E2. So let's verify the same thing here as well. So what I'm doing is, in my scenario, if you want to metric type behavior here, I'm taking these routes from RIP. From the RIP, the routes are getting redistributed into OSPF with a cost of 100. Okay, let's go and check on the router 3. The cost is 100. So what I'll do is I'll go to router 2 where I'm doing redistribution. I'll simply change the option here. I'll go to router OSPF 1. I'll use the same command. If you want, you can remove it, or anyway it will override. I'm going to say redistribute RIP, but this time I'm going to say metric type. We got two options. Default is 2. I'm going to say 1 here. Now once I give a metric type 1, if I go and check on the router 3 once again, you can see the cost changes. Now the cost is no more 100. This is something before, and now what I'm doing is, when I metric type E1, when I give metric type E1 here, this is E2, it changes to 164. Why it changes to 164? Because at the time of redistribution I'm saying 100. It's going to see the cost of this link. The link is serial link, and as per the OSPF calculation process, the serial link with 1.5 Mbps will have the cost of 64 based on the OSPF metric calculation, 10 to the power of 8 divided by bandwidth. So I know that calculation, so it's going to use the cost of 64 here. And similar way, if we have one more router here, let's say the cost is 30 on this interface. Once it reaches here, it becomes 194, something like that. It goes on add as it goes ahead. So the best practice Most of the time we define manual metrics, and also we prefer to use a metric type of E1. And finally, if you see the communication process between 1 and 3, it will communicate, and you can see the routes. And one more thing, I think I explained this one, E1, E2 routes. So this is how the output wise it looks. And the administrative distance remains the same for internal and external for OSPF routes, unlike EHRP.